Howdy, AJP students. This lesson will cover the basics of exponents. When working with exponents, several rules apply. Let's take a look at some of the rules for basic exponents. First, anything raised to the first power is equal to itself. As you can see in this example, y to the first power equals y. Next, anything raised to the 0 power equals 1. And here you can see m to the 0 equals 1. By definition, an exponent is equivalent to the base times itself, the number of times equal to the exponent. For example, x to the fourth actually just equals x times x times x times x. When you multiply like bases, you add their exponents, as you can see in this example. P to the third power times p to the fifth power equals p to the 3 plus 5, or p to the 8th. When you divide like bases, you subtract the exponents, and you can see that here. R to the 9th power divided by r to the 4th power equals r to the 9 minus 4, or r to the 5th power. When you raise an exponent to another power, you multiply the exponents. Here you see z cubed quantity raised to the 7th power. So this is actually z to the 21st power. You multiply 7 times 3. When adding or subtracting like bases, you can't do anything other than simplify by factoring out a common factor. In this example, y to the third plus y to the fourth, you can factor out y to the third, and the problem becomes, or it can be restated as, y to the third times the quantity of 1 plus y. This will come in handy later on. To convert fractional exponents to radical form, the number becomes the power, and the denominator becomes the root. As you can see in this problem, y to the 3/5 equals the 5th root of y cubed. The base stayed the same, the numerator became the exponent under the radical, and then the denominator became the root. If you have a negative exponent, this is simply the reciprocal of the positive exponent. Here you can see p to the negative 5th is actually equal to 1 over p to the 5th. This will come in handy very often on the SAT. Let's go ahead and take a look at the first practice problem. Here in example problem 1, the problem states, according to the equation below, which of the following could equal x squared? And we're given x to the 4th times x to the 6th divided by x to the 8th equals 81. At this point we should combine terms and then simplify to see what we'll actually get. We'll start by combining the numerator x's. So since we have x to the 4th times x to the 6th, we'll actually add those exponents to get x to the 10th divided by x to the 8th equals 81. Since we now have a common base in the numerator and the denominator, we can subtract the exponents. So we'll have x to the 10th minus 8, or x squared, equals 81. And if we take the square root of 81, let's go ahead and get our calculator out. So we have 81 square root, and that's going to give us 9. So x equals plus or minus 9. And if we look at the answer choices, answer choice B is positive 9. So x squared could equal 9. Let's take a look at the next example problem. This problem states that if p and q are each positive integers, which of the following is equivalent to z raised to the q power? Now, we notice that in our question and in all the answer choices we have variables. This is a great time to use the backdoor strategy. So we just need to pick some numbers for z, p, and q. I would suggest that we choose z equal to 4, p equal to 5, and q equal to 3. So if we plug this into our original problem, z raised to the q power, we'll have 4 to the third power. And so if we raise 4 to the third power, that gives us 64. So when we plug this into the answer choices, we'll be looking for the answer choice that gives us 64. Since this is the backdoor, we'll start with answer choice A since we have to do all of the answer choices. Here we have z raised to the p times q minus z to the p. And if we work this out, we have 4 raised to the 5 times 3. So let's go ahead and raise 4 to the 15th. That's going to equal a very large number. Now let's subtract 4 raised to the 5th power. And that's going to leave us with another very large number. And we know that that does not equal 64. So let's now move on to answer choice B. Answer choice B is the q root of z raised to the 2 times q. So we'll go ahead and work this out. And we have the cubed root of 4 raised to the 2 times 3, so that's 4 to the 6th. And so we'll go ahead and do that. 4 raised to the 6th equals 4096, and we'll take the cubed root of that, which gives us 16, which is also not 64. So let's move on to answer choice C. Answer choice C is z raised to the p times q over z to the p. Here we can substitute in, and we end up with 4 raised to the 15th divided by 4 raised to the 5th. So let's go ahead and work that out real quick. So 4 to the 15th equals another really large number, and then we'll divide that by 4 raised to the 5th power. And that's going to give us 1,048,576, also not 64. So let's move on to answer choice D. Answer choice D is z raised to the p divided by z raised to the p minus q. Here we end up with 4 to the 5th divided by 4 squared. And so let's go ahead and check that out, see what it comes out to. 4 raised to the 5th equals 1024 divided by 4 squared equals 64. So that does check out, so that's a possible answer. Now let's look at answer choice E. Answer choice E is 2 times z raised to the q divided by 2. So when we plug that in, we get 2 times 4 raised to the 3 over 2. So we'll go ahead and work that out. So we have 4 raised to the 3 divided by 2, and that's going to equal 8. Now we multiply that times 2, and we have 16, which is not the correct answer. So the only one that came up with the same answer was answer choice D. So we can mark answer choice D and move on to the next problem. Example problem 3 states, if 2 raised to the 500 minus 2 raised to the 499 times 2 raised to the 400 minus 2 raised to the 399 power equals 2 to the x, then x equals, and we have 5 choices here, 2, 4, 748, 898, and 900. Now this problem, if you recall from the rules, we can factor out some common factors here, and that's going to help you solve this problem. So go ahead, try this. It's going to be a little difficult, but see what you can do. And we'll actually go over this in class.